We're going to do a quick recap of the notes you might have missed in class today, or maybe I talked too long and you just step away for a little bit. So the first thing is this is page 5 of the notes, and I changed the very first example. I didn't like this example, so I crossed it off. I wrote a new example, and actually, if you're in my period 1 class, this is not even the example I changed it to, so this is different from even the one I did in your class. But the words of the song are the same. We're doing PEMDAS in reverse. I like to always write this little tower down for myself, just to kind of keep track of where I'm going. And the goal, of course, always is to try to get this x to be by itself by undoing what was done by doing the opposite. So opposite stuff in the opposite order. So we're going to focus on this x right here. We're going to start down here at the bottom, and we're going to look at this side of the equation, and we're going to say to ourselves, is there any addition or subtraction that needs to be dealt with? And if there is, I will do the opposite of that. So I can see in this example that there's a subtraction of 1. So I will do the opposite of that by adding 1 to both sides of this equation. These will cancel out, leaving a 3x squared on the left side. And 74 plus 1 is 75. I will then move up the ladder, as I like to say, and I need to look still at this side of the equation because my goal, of course, is to get this x to be all by itself. And I'm asking myself the very specific question about multiplication or division. Has any multiplication or division happened over here, and do I need to undo that? And the answer again is yes. Yes, I do. I need to divide both sides by 3 to cancel out this 3, leaving an x squared on the left side, and then 75 divided by 3 is 25. I will now move up the ladder, and I'll say exponents. Are there any exponents with that x that need to be taken care of? Squared is an exponent, so the opposite of squaring is square rooting. I'll do that to both sides. So the square and the square root cancel. And then because I, as the problem solver, am the person who put the square root in there, I need to include a plus or minus in my answer. And whatever number I can think of that multiplies by itself to make 25 is my answer. So that'll be 5. And I do want to point out that, like, at this point, when we have this x squared equals 25, we are looking for numbers that multiply by themselves to make 25. Both positive 5 and negative 5, they both do that. 5 times 5 is 25. Negative 5 times negative 5, also 25. And so I need to include both answers. But that's only because me, as a problem solver, put the square root in there. If you look at my other videos for Standard 2.1, if I just straight up asked you, hey, kiddo, what's the square root of 25? You would not put a plus or minus in that case because the original problem had the square root in there. You don't do it. You only do it when you, as a problem solver, put the square root symbol. So let's see that same steps in action over here for with letter B on your notes. I'll continue to use this green pen. We're doing PEMDAS in reverse. So let me just erase my checklist so I can start all over again, right? It's always this thing over and over and over again, right? We have a nice big fat wall through our equal sign. We want this to be by itself. We start at the bottom of the tower. And we say on this side of the equation, is there any addition or subtraction that needs to be dealt with? Yes. I have to add 76 to both sides because I want to get this by itself and this is on that side. It's got to go. These cancel. 0 plus 76 is 76. The left side is still a 4x squared. I move up the ladder. I say to myself, is there any multiplication or division happening to x that I should take care of? Yes. There's a 4, so I'll divide by 4, I'll divide by 4, get the old calculator out and discover that 76 divided by 4 is 19. I'll then check, move up the ladder, ba-ding! Is there any exponent to get rid of? Yes, there is, x squared, so I'll square root, and I'll square root, and me as the problem solver put the square root in there, so I've got to put a plus or a minus and then a root 19. Then I get to think about that fun list of perfect squares that we mentioned earlier in the other notes, and I need to see if any of these perfect squares go into 19. Because if there are any perfect squares that go into 19, I'll have to simplify that further. But we can see, I mean, maybe you even recognize 19 as a prime number, so you'll know it's not going to work. But if you have any doubts whatsoever, clearly 16 doesn't go into 19, 9 doesn't go into 19. Nor does 4. So this doesn't simplify any further. That is my final answer. I'm going to tackle the last two problems in another video. So that letter D definitely is very different. You'll want to check that one out. And if you can't tell, common theme, we're doing PEMDAS in reverse. PEMDAS in reverse. When in doubt, when you're feeling unsure, focus on understanding how PEMDAS in reverse is at play, and you'll do phenomenally. I have full faith in you.